Okay, we'll get started. Salai, are you able to hear me?
Yes, sir.
Okay. So look at this problem, start doing on your own.
Okay, sir.
Yeah. எனக்கு ஆல்ரெடி தெரியுதா? Record. What is the answer? So let's see. So let's see how to solve this problem. The question says, tell me. Yeah, this one we have solved it in the class. When? This is a textbook problem, I know.
Sir, I got the answer, I think.
There's a textbook problem.
Sir?
Yeah, tell me.
I think I got R is equal to 17 ohm.
Correct.
And V terminal voltage of the battery as 8.5.
Correct. So this is a textbook problem. அந்த கனெக்டர் எங்க இருக்கும்? அந்த கனெக்டர் பாருங்க. அப்படியே கொடுத்து solution. Yes. So there is a battery of EMF 10 volt and internal resistance 3 ohm. It is connected to a resistor. If the current in the circuit is 0.5 ampere, find the resistance of the resistor. So how to solve this? if I look at this being converted to a diagram, then there is a 10 volt cell which has an internal resistance of 3 ohm and it is connected to an external resistor of value R, which we don't know. What is the current through the circuit? Current through the circuit is 0.5 ampere. Right. Now there are two tasks. One is find the resistance of the resistor. We need to find this external resistance. So for that, what we will do is we will apply the concept of these two resistors being connected in series. So when I draw the equivalent circuit for the same, which is given here, then it will become R plus 3, and this is going to be 10 volt. And the current flowing through this is half ampere, 0.5. I'm writing it as half ampere. So can I apply V is equal to IR now? So V is equal to I into R effective in this case. So what is the value of V? 10 is equal to I is half into R effective is R plus 3. So this will go to the other side. 20 is equal to R plus 3, which implies R is equal to 17 ohm. So the external resistance is going to be 17 ohm. Then what about the terminal voltage of the battery? So for terminal voltage, we'll apply the formula V is equal to E minus I into R. Okay. E is how much? 10 minus I is half into what is the value of internal resistance? It is 3. So 10 minus 1.5 is going to give us 8.5 volt. Okay. It is going to be 8.5 volt. Okay. Make a note of this. That was for second batch, no? Okay. Shall we do the next one? Observe. Yeah. So do this. There is a battery of 6 volt EMF and internal resistance of 2 ohm, which is connected to a resistor. If the current in the circuit is 0.25 ampere, find the resistance of the resistors and the terminal voltage of the battery. So this one you can do it directly. So what is the answer?
Sir, is R 22 ohms
Yes.
and the terminal
Capital R
voltage
is
22,
22 and the terminal voltage is
5.5.
yes, it is 5.5 volt. Why even there is one potentiometer? That is 6 minus 5 is 0.5. Unit. You got the answer? Sure. So it is 5.5 volt. Correct. So it is exactly same to the previous problem. Only thing is there are changes in numbers. Okay. So you'll get it as 22 and 5.5. We'll do the next one. So network PQRS shown in the diagram has batteries 4 volt and 5 volt and negligible internal resistance. A milliammeter of 20 ohm resistance is connected between P and R. Calculate the reading in the ammeter. So calculate the reading in the ammeter or in the milliammeter. So what is that you're supposed to do? Apply. So you have more than one cell. Apply Kirchhoff's laws. Okay. So by applying KCL and KVL, you get an equation and tell me what is it you're getting. So let's say current supplied by the 5 volt battery is I. Okay. Let it get divided as I1 and I minus I1. Okay. So how many unknowns are there? 1 and 2. 2 unknowns. Take 2 loops, solve it. So what are the 2 loops that you have considered? Okay, what are the 2 loops that you are going to consider? You will take come again. So what is the loop? PSRP. Okay, when you take PSRP, what is the equation? From P to S, you are walking from higher to lower potential. So what should you write? Divya, tell me. What are you supposed to write when you're going from P to S? What will be the sign you give to EMF? So minus how much? Minus 5. When you go from S to R, you're walking in the direction opposite to the current. So opposite to the current means plus or minus or plus. Plus how much value? Plus I into 200. When you go from R to P, you're walking the direction opposite to current. So how much will you write? Plus I1 into 20. Right? So this value should be equal to 0. So if I take 5 to the other side, 5 will cancel this 240 times and this one 4 times. So this will be 1 here. 40i plus 4i1 is equal to 1. Make sense? Correct? So this is equation number 1. Similarly, if I take the loop PRQP, then what will we get? When you take it as PRQP, when you go from P to R, you write minus I1 into 20. From R to Q, you're going in the direction opposite to the current. So plus I minus I1 into 60. Then you're going from Q to P. It is going to be plus 4, right? This value will be equal to 0. So 4, this will get cancelled 15 times, and this will get cancelled 5 times, and here you have 1, right? So you will have minus 5i1 plus 15i minus 15i1 plus 1 is equal to 0. So 15i is equal to, correct only, no? 20i1 minus 1, correct? 15i is equal to, this will go to the other side as 20i1 and plus 1 will go to the other side as minus 1, correct? Yes or no? Yeah. So what should be the answer? So 15i is equal to 20i1 minus 1. Similarly, 40i is equal to minus 4i1 minus 1. So multiply this equation with 5 and then solve it. You will get the value of I. Once you get the value of I, substitute it back, you will get the value of I1. So what is expected in this problem? I or I1? Calculate the current through the milliammeter. Milliammeter means I1. So what is the value? Anybody with the answer? Anybody with the answer? What is the value of I? So I will be equal to 4 divided by 2 and 5. Take that and substitute it there, you will get the value of I1. So you got the same answer yesterday with a minus sign. So minus sign, what did I tell? Now you understood the importance of direction. Done? Shall I proceed? So what is the value of I1 here? I1 is 218 by 215. Huh? Possible. Okay. Next. Eight by 43. Yeah. If you have to get 8 here, then you should get 40 here. After 4 by 2 and 5, you substituted where? This one, huh? Okay. So you will have 160 divided by 2 and 5 plus 4I1 is equal to 1. Yeah. Okay. I think this is correct, no? This number. Yeah. Shall we proceed to the next one? So it's a similar problem. Yes, we'll do this. So use Kirchhoff's rules to determine the value of the current I1 flowing in the circuit shown in the figure. Okay. So how to solve this? Let me label it as A, B, C, D, E, F. Okay. Our job is to find the value of I1, right? So how many unknowns are there? You have I1, I2, and I3. So 3 unknowns. We need 3 loops, right? So we'll take 3 loops into consideration. The first loop that we can think of is A, B, C, F, A. Right? When we think of A, B, C, F, A, then what is going to be the mathematical equation? It is going to be minus 30 I1. When you go from B to C, there is no resistance. So when you go from C to F, there is a battery source. So it is plus 20 volt minus 20 times I3. Everything put together is 0. Right? So 1, 2, 3. 3 elements, 3 terms. Right? Sum of everything put together is a 0. Similarly, when you think of FCDEF, right? When you look at FCDEF, when you go from F to C, you're walking in the direction opposite to the current. So it will be 20 I3 minus 20 because you're walking from higher to lower across the cell. And when you go from C to D, there is nothing. And when you go from D to E, again, you're walking the direction opposite to current. So it will be plus 20 I2. And here you're walking from higher to lower potential. So it will be minus 80. Right? Everything put together is going to be a 0. So what is the other loop we can think of? We can think of the bigger loop, that is A, B, D, E, A. So when you go from A to B, you have minus 30 I1, right? Minus 30 I1. So when you come from B to D, there is nothing. From D to E, you have plus 20 I2. Then you have minus 80. Everything put together is going to be a 0. Okay. See, but the problem is you will get this equation by adding these two. So this cannot be considered as a valid equation. I need to check if there is any value that is given in the problem. Okay. See, listen. Actually, there are three unknowns, no, I1, I2, and I3. But actually, there are only two unknowns. Why? Because if you see, I1 is a current flowing through the junction C. So out of I1, if I3 gets divided here, how much will be the remaining current that is flowing? I1 minus I3. So I1 is flowing towards the point C. From point C, what is happening? I2 is getting divided across the branch CF. So how much will be the remaining current flowing? It will be I1 minus I2. But remember, I1 minus I2 should have flown in this direction. That is in the clockwise direction. But I2 is given in the anti-clockwise direction. So I1 minus I2 is going to be negative of I2. Sorry, not I2, I3. So I1 minus I3 will be the negative of I2. Are you able to understand? So you need to take this and substitute it in any one of the equations so that it will become equation of two variables. So you have two equations and two variables, you will be able to find the value. Do it fast. Because according to the way, if you see at point C, I1 is entering the junction, I3 is leaving the junction. Okay. So if I1 is entering and I3 is leaving, what should be the current that should be coming out of C? I1, I1 minus I3. I1 minus I3 should have actually flown from C to D. But what is the direction they have given? Answer? Anybody with the answer? Negative means the direction of current assumed is wrong. That's it. You're getting I1 as I3 as possible. So here the meaning of this minus 3 by 4 is whatever is assumed here, the direction that is assumed for I1 is opposite to the original direction. That is the meaning of it. Got it? Yeah. Meaning I1 is actually not flowing from A to B, it is flowing from B to A. That is the meaning. Okay. Try this. Let me check if there is an answer for that. It's not given, but we'll see. So battery of EMF E and internal resistance R when connected across an external resistor of, it is not 12 feet, it's 12 ohm, produces a current of 0.5 ampere. When connected across a resistance of 25 ohm, it produces a current of 0.25 ampere. Find the EMF and the internal resistance of the cell. Convert it to a diagram and then do it. The previous one, this answer I got, like whatever is told, I wrote it. I1 is minus 3 by 4, I3 is 17 by 4. Okay, if anyone else is having the same answer matching, let me know. But why are you taking so much time to solve a linear equation? What is happening? All that you need to do is, in the place of I1 minus I3, or for that matter, wherever I2 is there, replace it with minus of I1 minus I2. Wherever I2 is there, this place, replace it with I1 minus I3, no? Then you will get two linear equations in I1 and I3. Just solve, you're done. I'm not sure why are you people taking so much time. Anyways, do this one. How many of you got that? You also got 17 plate. Maybe that's the answer. And what was the other value? 17 by 8, 8, okay, then 17 by 8. So everybody got minus only, because it's a common diagram for all. Yeah. Solve this. Convert it to a diagram and then do it. You first draw the diagram, only then you will understand. Did you draw it? Okay. There is a battery of EMF E and internal resistance R when connected across an external resistor of 12 ohm. So in first, this battery is connected across a resistor of 12 ohm. Then what was the current through the circuit? 0.5 ampere. That is done. This battery is removed from the 12 ohm. Now it is connected to a 25 ohm resistor. Now what is the current? 0.25 ampere. Using these two data, find the value of EMF and the internal resistance of the circuit. I did a similar problem yesterday. That graph thing. You can check your notes. I did a similar problem. I gave you the formula also. Where a note is same, as Listen. A battery of EMF E and internal resistance R. So there is a battery of EMF E and internal resistance R. When connected across a 12 ohm resistor, there is a current of 0.5 ampere flowing through it. So EMF is E and internal resistance is R. Okay. Now I have another circuit where the same cell with the same internal EMF and with the same EMF and internal resistance is connected across a 25 ohm resistor. Now the current is considered to be 1/4 of an ampere because it is 0.25 ampere, right? Now the question is, what is the value of capital E and small r? So two unknowns, you need two equations. That is why they gave two conditions. Okay. So if you observe, the equation we are supposed to use here is I is equal to E divided by capital R plus small r. Okay. What is the value of E that we don't know? Divided by what is the value of capital R? 12 plus small r also you don't know, right? But what is the value of current in this case? It is 1/2. So cross multiply, 2E will be equal to 12 plus R, and let this be equation number 1. Similarly, in the second case, I will be equal to the same formula, E divided by R plus R, which implies E divided by what is the value of R? 25 plus, so capital R is 25, small r is R only, is equal to 1/4, which implies 4E is equal to 25 plus R. So let this be equation number 2. Solve both, you will get the answer. So subtract first from second. So do 2 minus 1, you will get 2E is equal to 25 minus 12 is going to be 13, which implies E is equal to 13 divided by 2, which is 6.5 volt. So take the 6.5 and substitute it back here. You will get 13. So 13 minus 12 is 1. So R is equal to 1 ohm. EMF is 6.5 volt and the internal resistance is 1 ohm. Done? Copy it. Do it fast. Whatever. So try this. So using Kirchhoff's law, obtain the balance condition for a Wheatstone bridge. So what is the balance condition for a Wheatstone bridge in this case? So the ratio of the resistors at the top from left to right should be equal to the ratio of the resistors at the bottom from left to right. So in this case, 2R divided by 2R should be equal to R divided by whatever is this value. Okay. Now, calculate the value of R in the balance condition of the Wheatstone bridge if the carbon resistor connected across the arm CD has the color. Okay, color sequence you don't know. Color sequence is not a part of your syllabus. First part you can leave. Second part is, if now the resistances of the arms BC and CD are interchanged. BC and CD are interchanged to obtain the balance condition. Okay. This also you can't solve because color code is important. See, just to give you a heads up of what that color code is, I'll show you something. See, this is called as a carbon resistor. It is this small. Okay, this is a carbon resistor. On top of this, you will have color code. You can open your textbook and go to the color code page. I'm not sure if they have deleted it. It's a revised book, no? Color code. Yeah, they've deleted. There'll be a table actually. Okay. So if you observe here, no, how many colors are you able to see? You're able to see 4 colors. There will be 4 colors on top of this. Okay. So you can observe a resistor in 2 directions because it does not have a positive and a negative. So 4 colors I showed you like this, right? Where here it starts with brown and ends with gold, or I can say like this also. Or I can show it to you like this also. With respect to you, starts with gold and ends with brown. Okay. You should always ensure that the last color is either gold, silver, or no color. Okay. And you talk about the first color starting from the other end. So how are you supposed to hold it? You need to ensure that your right hand side has gold, silver, or no color. And left hand side, you need to look at the color with which it starts. So each color has a number associated with it, which is called as the color code that is given here. For example, if you look at this problem, it is RRO, means red, red, orange. The 4th color is not given. Okay, when the color is not given, there is a meaning for it. I'll tell you what it means. Are you able to understand? So when you look at this number, the first color has a significance. Let's say in the table, R represents some number. Okay. So BBR, it will come as 2. Okay. So this has number 2. Similarly, this R also has number 2. Okay. So it is basically 22. So first color's number, you need to write it in the tens place. Second color's number, you need to write it in the unit place. Then you will put an into. You will write 10 to the power of whatever number this color represents, whatever number the 3rd color represents. Okay. So is there a table there? What is the number for orange? Tell me. What is the page number? You have an old textbook. Huh? New one. Huh? What is the number for orange? 10 power? Yeah, orange would have numbers. 3, no. So 10 power, you need to write that number. So first digit, second digit, and the third is a multiplier, right? And the 4th one, if you observe, there is no code. What is the page number? If you have textbook, you can have it. You can show it to them. So it's able to see there is a resistor given there, no? This is the one. It is this small actually. Okay. So what is the color given there? Red, 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 and the last color is silver. Did you understand what you're supposed to do? So first number, write it as it is. You need to pick from the table. Second number, you need to pick from the table into. The third number is called as multiplier, 10 raised to the power, whatever color code that number has, right? And fourth has no color, means no color, there is something called as tolerance. Tolerance, what are there across 5? Across silver, across color. That is the meaning. Tolerance is like an error. Plus or minus 20%. What
Sir, your voice is breaking.
Voice is breaking. Is it clear now?
Yes, sir.
Okay. Did you understand the concept till here? Yes. That is why that is how it is represented. If other colors have tolerance, then you will not know which side you need to see the resistor. That is what I told you in the beginning. No. Always, whenever you look at this, I'll say it is like this. The one which I have in my hand is like this. Okay. I'm able to see a brown here. Okay. I'm seeing a black here. And again, I'm seeing a brown here. And the last one is a gold. This is how it is there. So how will I know which side I'm supposed to see? This decides. If suppose I had put brown on other side also, you'll not know which side you're supposed to see. Okay. So always ensure that this gold, silver or no color always falls on the right hand side. So left hand side should be the other colors. See, for example, the one which I have in my hand, brown, black and brown. Tell me what is the value of it. Brown is how much? Okay, black is 0 into 10 power, brown is 1. Okay, so what is the value? 100 ohm. Did I bring the sheet here? Did I bring the small sheet here? Huh? So this is the sheet. See, this is the one which the manufacturer gave. What is the number here? Matching. So it works. So this is the one they gave. So that's why you use color code to just represent instead of telling the number again and again, because it's difficult to print also on top of this. So that's why you have this color code. And the name of this kind of a resistor is a carbon resistor. It will tell whether how much error is there. So can we try to measure it across an ohm meter? I'll show. Is there a multimeter here? Okay, 1 minute. How much is the value? So calculate the value of R in the balance condition of the Wheatstone bridge if the carbon resistor connected across the arm CD has the color sequence of red, red, and orange. Meaning, if this is 2R, okay, tell me one thing. If this value is 2R, how much is this? This is also 2R, right? Hence, the upper part says 2R divided by 2R, the ratio comes out to be 1. So what should happen at the bottom? R divided by the resistance of this one should be 1. So putting it simple, this is the value of R itself. That's what they're asking in the problem. Now, what is going to be the value? You have red, red, orange. Red is how much? I think we wrote it already. 22 into 10 power 3. So it is basically 22 kilo ohm resistor. Okay. Now the next question is, if now the resistances of the arms BC and CD, resistance of the arms BC and CD are interchanged to obtain the balance condition. Another carbon resistor R is connected in place. Another carbon resistor is connected in the place of capital R. What should be the sequence of the color band of that carbon resistor? So what they are doing is they are bringing this 2R here. This is taken here, right? So what will be the value of resistance here? It will be R. Now what is the condition? 2R divided by R. It is 2. So here how much you have? R. Then how much should you put here to get the balance condition? You need to put R by 2. See, left hand side is double the right hand side. So you need to put R by 2. They're asking what is that value. If you find that value, you need to write, they're not expecting the value. What should be the color sequence of that particular resistor you need to connect to make it a balanced Wheatstone bridge? So it will be 11 kilo ohm. 11 means you need to write the colors. So 11 means what is the first number? Black and brown. So brown, brown. The third number should be a orange only. So it should be brown, brown, orange. Okay. So I hope you're able to understand. This is how it works. See, I tried to cover everything that is possible from this chapter. So Friday you have a test. No, tomorrow I'll be starting the next chapter. That is magnetic effects of current. The only difference between what you learned in your 10th grade and the one you are going to learn tomorrow is you have a lot of derivations. There you learn theory and mostly about rules, right hand thumb rule, Fleming's left hand rule, right hand rule, all those things. Here, in addition to learning all those things, we need to see the derivations. Okay. So wherever integration is needed, I'll teach you at that point, and then I'll go into the concepts. So tomorrow's class, be prepared that we'll be starting a new chapter. Yeah. We'll wind up.
Thank you, sir.
Yeah.